Okay, that's better. So I'm going to start by actually looking at your resource groups. So in the resource group, you have the ability to assign a calendar, and the calendar is how the system figures out the capacity in that resource group. For example, if I look at this calendar, working 18 hours a day, Friday. Now, what you can do is when you set up your calendar, you can actually make this default hours of 24 and then select the 18 hours that you're actually here. Because right now the system is saying that it could schedule a job to be run at 1 o'clock in the morning on Monday because the system thinks that you're there on Monday at 1 a.m.
Is that true, guys?
So we start our third shift Sunday night at 10 o'clock.
Resource group is only showing that this particular resource only works 2 shifts or 18 hours a day. Is that correct?
Yeah.
So do you have some
shift
resources and resource groups that work 2 shifts and some that work 3 shifts?
No, we have third shift works 5 8-hour days, and then first shift works 4 10-hour days.
Hours, 4 days a week shift?
That's first shift, and then third shift works 5 days a week, starting Sunday night, 8 hours.
Your calendar should reflect that when the resource group is out. Waterbury trimmer have available to it 16 hours a day starting at 1 a.m. in the morning, Monday through Friday.
So we need to change that, is what you're saying, Jim? We should change that schedule.
So you can have a calendar. If the system sees a calendar on a resource, it uses that. If it sees it on, if the calendar, there is no resource on the calendar, then the system says, I'll use the resource group calendar. So typically what you could do is any resource that works differently than the resource group it belongs to, that's where you could put a calendar on the resource. Otherwise, use the resource group calendar. Also, a field called Finite Horizon is resource and the resource group. What that's used for, identify is infinitely loaded. So this box through the finite.
Scott, excuse
Hey
me a
guys,
second.
if you're not, can you guys mute except for Jim?
There we go.
So if you have a resource that's finite loaded, you want to check this box off that says this resource is finite capacity. And then what you can do with that finite horizon is you can tell the system after this amount of time when the scheduling engine runs that even though this is coded as a finite capacity resource, schedule it infinite. So for example, some customers might say, you know what, for the first, 30 or 60 days, 45 days worth of scheduling, I want to schedule infinite, finite. After that, just to make the scheduling engine run faster, I'll go and say after 45 days, schedule it in a infinite mode, because I realize that I will look at that job multiple times as it gets closer and closer to the date, and it will be picked up and scheduled in a finite mode as it gets inside the 45 days. If you leave it blank, now the system says, if you have a job demand out there for a year from today, I'm going to schedule it in a finite mode. You don't have a lot of jobs that are, a demand and jobs that are out there way out in the future. You can certainly leave this blank, and now the system will schedule anything that goes through this resource if it's checked as finite capacity in a finite mode.
So typically, Jim, you would check that box and put in a horizon.
Or again, if you don't have, if you don't have jobs that are far out in the future, you might very well just check this box and not put any horizon in. And again, being that this is the only resource in the resource group, you could put the horizon over here, or what's important is if you want to schedule this in a finite mode, you'll want to check this box to make sure that the system knows that if you have 16 hours a day, then it will never schedule more than 16 hours a day into this, against this resource.
Okay. Well,
if it's infinitely loaded, then what the system will do is that's where the tools like the overload informer comes into play. I'm going to go up to scheduling, general operations, and I'll go into the overload informer. And what the overload informer will do is it will tell you any resource that is not finitely loaded that has more work in it than it can handle. So for example, you can see what I did was I went in the overload informer, I did a refresh under actual, and I can see, for example, that on 8/3/2013, that number 3 Waterbury trimmer, it has a capacity of 16 hours, and what was loaded in it was 18 hours over its capacity. So it said it was 100% overloaded. And then on 11/24, that same resource group was overloaded again because we have 7.66 hours over its stated capacity. So we're 42.56 overloaded. So any resource any resource that's not finitely loaded, the system is saying, I'll handle it in an infinite mode, and I will overload it, but I will tell you when you're in an overload condition. And then actually right from this screen. Let's find something that's not too far out, or not in the past, is what I should say. I can jump and say open with the resource group scheduling board. And now, what I'm looking at, I'm going to make this full screen, is the resource scheduling board, and showing you what operations to make what parts are scheduled through this number 56 national header, 203B. And if I go here, it'll show me the operation codes. It'll show me the setup group, the start date, days late, and whether or not the job is actually locked or not. And what I can always do is I can say start time, and that actually brings that job right up to the beginning where it's scheduled. And I can see that this job is late. I know that because it's highlighted in red. If I go to the details is telling me that that's what I'm making. I'm making part 8018. Here's my production quantity. Here's my quantity complete to date, which are none. It's operation 10 on that job. It says it was to start on 11/10/2014 at 12 a.m. It was due to be complete on 11/11 at 2:15 p.m. Remaining hours are 32.25 hours. I'll close this. Close my overload former. Go back to the resource groups. Actually, let's do this. I'm going to go into part tracker. I'm going to call up that job, or that part, 3400. I'm going to go to revisions. Okay, so there's one revision out there. I'll put my mouse in with that revision and say open with method tracker. So I'll jump to the view only of the engineering workbench, if you will. I go to the operations, and I can see that there's the operation. You got an hour's worth of setup. You have a production standard of 48 pieces a minute. If you go to the tab that says Scheduling Resources, I can see that when we create a job, it'll be scheduled to the number 6-B, Waterbury, Farrell, DNF. And shows, but I might be able to call up the resource group and look at the resource. When I close the method tracker, it'll just bring me back into the part. I'm going to jump to time phase. And I'll call up job right here. I'll go into job tracker. So there I see the job number, I see the part number, I see what you're making. You're making them to stock. The production quantity is 240,000. To date, you've reported 235 pieces. We look at the operations. There we can see an op 10. Op 20 is an outplan operation. I can tell that just by the symbol here. Then it comes back for op 30. And you have op 40, which is your packaging operation. One of the things you'll want to make sure you do is you need to have a days out. How long from the time you send these parts to this guy to galvanize them till they come back galvanized? Because when the scheduling engine runs, you'll notice here it said you can start this on 7/21 and it will take you to 7/28 because you need a total of 83.33 hours. Then when you go here, the days out will come into play so that when you look at this operation, it will tell you when are they due back. Right now, this operation is ending on 7/28, and the system thinks from a scheduling point of view, you can start them over here on 7/28 because the system says galvanize is taking no time at all. So it's important that the field days out is populated so that when a job is created and then the scheduling engine is run, that the system knows that it's going to be at this galvanizer a week, let's say. Then what you would see is the system would say it's going out when this operation is done on the 28th, and it's going to take a week, so this operation would start a week after the 7/28. So here, when you create the method, So again, I'm in method tracker, that's why I can't change this. But here is where you would put the number of days out so that when you create a job and pull the method into the job, if this says 5 days, it's going to come over for 5 days. At the job record, you can change it, but here, at least you have a value, and that value will become part of the job when you go up and say, go get my details, just like the job took the value here where you said for this operation, you can do 48 pieces per minute. I'm going to copy this operation. I'm going to go into the operation folder for a moment. Back at my job tracker. So when you create your operations, you needed to link them to either a resource or a resource group or two resources or one resource group. If you use more than one, so if I have an operation that's linked to more than a single resource or resource group or one resource and one resource group, on this front screen, you need to tell the system what is the primary operation detail. So when the scheduling engine runs, it looks at the primary first. So in this case, it looks to see if that machine is available.
Now, on this one right here, I found that if you had two resources attached here, that it would double schedule that it would require both of them. Is there something in the setup there that's not accurate the way we're doing that? Or how do you get that to only look at one of them?
Well, on the resource group itself, so let's go back to a resource group. You always want to watch out for the scheduling blocks. What the scheduling block says is if you had multiple resources within a resource group, would you in turn say that let's say both of them are going to work on the same job simultaneously. So think of, if a machine had, if you had, you were making a part and you had two resources in the resource group, you could schedule to the resource group, and then if you had scheduling blocks equal to 2, now the system will say that each of those machines would be working on the same job, same operation at the same time. So that would imply that if there was tooling involved, that you had more than one tool to be able to set both machines up to do that. The scheduling block portion is also available to you when a job is created. Now again, I'm in a job tracker, but if you saw that a job was running late, you could simply say, I'm going to need a total of 83.33 hours, but I will split that among however many resources I have in that resource group. And let's say you had 2, you could change the scheduling block right here on the job to 2. And now what the system would do is it will schedule 40-some hours on one resource and 40-some hours on the second resource. Because you're saying, I'm going to use multiple resources to push this job through and try to make up for some lost time. Otherwise, right now, the way this is scheduled, it's saying that it's going to find the resource and it's going to schedule all 83.33 hours on that one resource. If we go look at the job scheduling board, again, I'll do the start time, which will bring this into focus here. Make these a little bit bigger. Right away, I can see that this job is late, and I know that because it put a red line across the top. If I click the folder, I can see that op 10, this green is showing that op 10 has been completed. Again, because we didn't put any days out, the system thinks that it could finish on this date and the next operation could start. And if we look at the next operation, we see completion on the next operation, and now we're up to the packaging operation. Again, I can always go to the details and see that op 30, estimated hours were 58.14, it's 100% complete, and they completed 243,593 against the required quantity of 240,000. So it looks like the only thing left to do is the packaging operation. Now, the system is saying this job is late because here's when it's going to finish. And if we go back to the job tracker, he said it was required to be done by July 21st, and the scheduling engine said it's not going to be done until 7/31. That's why it put that red banner across that job saying that the job's scheduled finish date from the scheduling engine is later than the required by date that you initially asked them to be available for. Also, the system thinks that there'll still be another 5,000 pieces that are going to be built, and if that's not the case, then when you go and into the program to complete the job, you'll tell the system that you're calling it quits at 5,000 pieces short, that you're not going to make those additional 5,000 pieces. So, for example, if I go up here and I go to labor transactions and do a retrieve, just turn on sum, so the setup was done, and then the first person reported 25,000 and 22, 38, 27. And someone logged into the job, didn't report any pieces complete. Then 9,000, 4,000, 15, 59, and then they 5,000 and 7,000. That got us to that quantity there. There's the individuals, and there's the system earned hours and the estimated efficiencies. Let's take a look at this resource group. Now, do you know, are any of the resources group coded as, or resources coded as infinitely scheduled yet?
I don't think they are, Jim.
Okay. So that's why everything right now is being scheduled in an infinite mode instead of finite, and whenever the system sees an overload condition, it pops on the overload informer. Now, some of the things you need to be aware of when you finitely schedule, that you could wind up seeing gaps in your schedule. So what I mean by that is, if I go back to this job tracker, go to the scheduling board, You could see a situation where op, and for the moment let's forget that op 20 is an out plan, or we'll leave it. You might see op 30 after op 20 is complete, not starting for 3 or 4 days later. Well, that's because if that operation is being finitely scheduled and there is already jobs scheduled on the date where the scheduling engine would like to put op 30 for this job, it can't overload, so it has to go and find other places to put it. Now, it will usually try to put it to start earlier, but that's not going to always work because the previous operation might not be complete, or there could be a material constraint. So instead, the system starts to look in time in the future, and let's say it drops it to be run on August the 7th. Well, now you see one operation ending on July 31st, and you would think, well, then why doesn't it start to run on July 1st? Well, because there is no available capacity on July 1st on where it needs to run, and so then it looks to 4th. Is there capacity on the 4th? If there is, it'll drop it there. If not, it says I got to look at the 5th, and so on. And so occasionally you will see gaps in your schedule. And that is due to the fact that you are finitely scheduling as opposed to infinite, and under finite it cannot overload. So if the resource says I got 16 hours a day, the system says after 16 hours a day I got to go look elsewhere to put a job operation. And so you can wind up with gaps in your schedule.
When you say gaps in the schedule, what you really mean, though, is the utilization of the resources there, though, right, Jim? I mean, the resource is always going to be, it's always going to be doing something.
It's not just what you, it's not going to be running directly after this like you would think, and that's an indication that it could schedule it to run on July 1st because there's already something in this resource group on July 1st.
Right, there's something else running on that resource. That's why there's a gap.
The other thing is you need to understand that when you finitely schedule, you're kind of taking the scheduling capability, if you will, kind of out of the hands of the scheduler, and you're letting the system do the schedule. So what I mean by that is, to close this one, I'm going to go back to time phase so I can get a job not in the past. Take this job, it's a little bit better. Whenever you get that message, that says you already got that occurrence open. And so if I hold down my shift key and then go to job tracker, it'll open it up with the new job instead of the other job that was out there. So here you can see that the operation 30 is showing complete, or has some completion in it, but we still have some more to go. So for example, if I go look at details, I can see that there's a remaining hours of 14.49 hours. See, now this job, and that's what I was seeing on the scheduling board, someone did put that it takes 7 days. And so that's why this operation is scheduled to start on 9/11, due on 9/16. If we look at this operation, it's going to be done on 9/18 because then it's taken into account the 7 days we need for the galvanizer. So that's why I jumped back to the job tracker, because I noticed in the job scheduling board, unlike the previous one, where there was no time, we are seeing that there was a stretch of time.
Jim, how do I look at the scheduling of a resource?
Okay. So when I go here to the, I went to operations, I went to details, I found op 10, which is this operation. When I go to the scheduling resources, I see where it got scheduled. And if I say open with the resource scheduling board, now I'm looking at, there are two job operations. And this is where they're scheduled. And oh, by the way, you'll notice that the 17th is in red. Well, because the system, if we were to go to the overload informer, we would find that on November 17th, we're overloaded because we have more work, we have more load than we have capacity in this particular resource. And if I look at the details, it's going to give me the job. There's the estimated hours. There's the remaining hours. Go back to the schedule. I can see that this job is 0024876 op 10. And that's scheduled for 84.33 hours to start on 11/17 and be done on 11/24. Now, one of the other things that you'll see when we're in a infinite mode I can go ahead and move an operation pretty easily. And The blue line indicates where it was. The yellow now is where I basically dragged it to. This isn't a committed change until I go up to Actions and say accept the change. If I say undo, it puts it all back to where it was. When you're scheduling a resource that is flagged as finite, you really can't do this, because when you go to schedule, let's say you're in job schedule and you want to move an operation up, well, where you're going to put it, there might already be work there, which means you'd have to find out what's in its way. You'd have to move that first. And where you put that, you might have to move something out of its way. So to compensate for that, system under scheduling has this global scheduling option. And what global scheduling does, it says, I'm going to look at the entire shop and I'm going to reshuffle the deck because you just have way too many jobs for you to do it manually when you're in a finite mode. Because infinite's easy. I go into any job in the job entry screen or the job scheduling board, and I can move an operation around, drop it where it is, and then later on when I look at my overload informer, I might find out what I just did was where I put it, and we have 16 hours of load, 16 hours of capacity, I now have 18 hours worth of load. Because the system let me do it because I'm in a infinite mode, which says you can overload me. The overload informer will show where I'm overloaded so that we can take a look and say, all right, can we have somebody stay, a couple people stay overtime to get rid of that load? Maybe where I'm overloaded on Thursday of this week and on Wednesday I'm underloaded. So I can manually move something up and drop it there and say, instead of being run on Thursday, I'm going to run this job operation on Wednesday. Fairly easy to do. The system will show you where you're over and underloaded through Overload Informer and other tools. But in a finite world, the system says, that's not so easy because I just can't drop it anywhere I want because I can't overload. So it provides you with this 3 programs. The first program is Calculate Global Scheduling Order. And what that does is when you run it, it will go out and it will show you how it plans to schedule a shop. And what you'll see is and see if there's anything out there already. No, there's not. What it will do is the scheduling sequence will tell you when the system plans to schedule that job. The lower the sequence, the sooner it's going to be scheduled. Well, when you're looking at this, if you see a job that, let's say, has a scheduling sequence of 140, and you want it to be scheduled first, and the first scheduled sequence says 10, you could change right in this screen that job scheduling sequence from 140 to 5. And then when you save it, and you run this program called Global Scheduling, what the system will do is it will look at that scheduling sequence and That's how it will perform its schedule. You can run this in the what-if mode. That's what that what-if schedule only is checked. And now, after it schedules, you'll be able to go look at tools like I'll show you them. Change Impact Informer. And that will show you, there's two sections. There's an actual section and what if, and it will now tell you what's sitting here in what if. It'll say you started with 78 jobs, let's say, early, and now, after running the reschedule engine, you have 80 jobs early, and instead of maybe 65 jobs on time, you have 75, and your jobs late went down from 331 to 100 and something. How does the system break a tie when it sees two jobs competing for the same resource or resource group on the same day and in a finite world? Well, it takes into account your scheduling priority code. So currently, every time you create a job, because normal is set as the default, the system says, I'm going to schedule this job using the priority code of normal. If I create a job and I change the priority code, let's say, to high, now when this job gets scheduled, and let's say there's another job looking for that same resource on the same day, it will look at the scheduling priority code. It'll take that into its factor, and it will decide at that point which job gets scheduled first. Most likely it'll be the one with the scheduling priority code of high. You can create your own scheduling priority codes. You don't have to use ours. The important thing to keep in mind, though, is that this number only means something in relationship to the others. So, for example, you saw normal was a 10, high was a 20, very high is a 40, very low, I would expect to be lower than normal and lower than low. So those numbers, I could use 10,000, 8,000, 3,000. They really don't matter. What matters really is their relationship to each other, because when the global scheduling engine runs, it's going to look at how late a job is, if it's late already, and a job could be not late, and then it will look at the scheduling priority code, and that's how the system will make a determination when it goes to schedule where that job gets scheduled, which job basically breaks the tie.
So Jim, if I have, as an example, I have sales orders that are in the system creating demand, and I've got 50,000 on one, 75,000 on another, and say 30,000 on a final one. How all of that could be accomplished by one job. How do I combine that together so that the demand appears, how do I reassure myself that I'm meeting the demand with the job schedule?
Well, now, are all of those, are you building everything in stock, or are any of those make to order in which you're shipping from WIP?
Well, in Telefast's case, it's mainly make to stock. There are some make to order, but
so in job entry, every job has a demand summary. In other words, why am I making it? So if I go into, let's say, time phase for this part, I can see your minimum on hand quantity. And so right now, you only have 16,800 on hand, so you're below your min. So you have a job out there. And the job is to make 31,687. And then you have another job out there, a suggestion for a job, to make 250,000 to satisfy this sales order. And you have another job to, this job is released to make 250,000. You're getting a message here to expedite this job. But basically, what you could do is, I could go here, and because I'm making the stock, I could say, you know what, I want to change this to encompass the demand that I have for November and December in one job, because I don't want to have a job to make the demand for December and then another job for December's. If you're making something to ship from WIP, in other words, it's a non-stock item, when you go into your job manager, over here, you will see all your demand, and then it will tell you how you're planning to cover that demand. So let's say you had a non-stock item, and the customer gave you a sales order and said, I want 150,000 in 2 weeks, and I want another 150,000 a week later. What would happen is when you went into your job manager, you would see those two demands sitting here in the demand tab. You could highlight the first demand and say, create a job. But now, on the second demand, you can say, you know what, I don't want to create a second job and run it through the shop a week later. I will combine those. What you would do is you could highlight the second demand, highlight the job you just created, and when you click the link button, the system will put those two demands together. And let's say that you had 150,000 and 150,000, you get a single job for 300,000 to be done on the date of the first demand. And then when you looked at the job through job entry or job tracker, what you would see down here is make to order, and if you did a list, you could see that it's satisfying two sales order demands. They could be from the same sales order,
Gotcha.
They could be from separate customers, separate sales orders. So you could have a job to make $350,000, and that's because 50,000 are for sales order 52, and 300,000 is for sales order 79. But you can absolutely combine, and if you're making the stock, even though you're seeing the suggestion that says you should make this amount, you could increase them. Now, do you run MRP?
Yeah, they run MRP.
So MRP is going to create an unfirmed job that you can firm up, but then change the quantity and say, MRP created me 2 jobs to make the same part 2 weeks apart, and right now the shop is really not that busy, so I'm going to firm up the first job, then change the job quantity to encompass the second unfirmed job, and I'll make the entire quantity in one job instead of doing what the system did as a suggestion, which was to create 2 separate unfirmed jobs, one running in the shop this week and running in the shop next week. Yeah, so right now if I go into the job, and if I say, show me unfirmed job, MRP created this job, but it's an unfirmed job to make $15,000 for stock. And if we go into the time phase, we can see that you said the minimum on hand was $15,000. You have $31,000 on hand, so you're above your min. Then you had this MRP job for $15,000, which would bring you up to $45,000. You have a sales demand on 11/4 for $20,000, which will drop you down to $26,000. You have another sales order for the same date for $10,000, which will bring you down to $16,000, which is why you got that job for $46,000, because that is going to bring you down below your min. Then you have another unplanned MRP job, or a planned unfirmed MRP job for $24,000 to cover that next sales order that is due to be shipped on 1/20. And once you ship that, you'll be left with $16,000, which, I'm sorry, $15,000, which is what you said you wanted to keep your min as. Really, the only question would be, why hasn't that MRP job for $15,000 due on 11/14, when you go in, as you get closer, when you go ahead and firm that up, then when that job is done, you'll have $46,000, which will be enough to cover the next 2 sales orders, and then in January, you have another job that should be firmed up to make $24,000 to cover the sales demand that is supposed to go out on 1/20. Now, are you using the job status maintenance to firm up your jobs? Or are you going into job entry and finding your unfirmed jobs and firming them up there?
Job entry. They use job entry, Clinton said.
Okay. And that works fine, but you could also use job status maintenance, because job entry, you're doing one at a time. Well, if I go to job status maintenance, I say show me my unfirmed jobs, sort by start date, now I'm just going to grab a couple of these. Right from here, I can say, okay, I'm looking at all of these jobs. And there's the start date. I can check, I want to firm them all. I want to release them all. And I want to set them all for mass print. And when I'm done, instead of going into job entry one at a time and doing this, I can go ahead and do them in mass. And when I hit process, what will happen is these job numbers, the MRP will disappear, use the next job number sequence. The job will be marked as firm. Check it that you want to release it or not release it at this point, and you can set it up so that it's set for mass print, which means when you go into either the job, you can print the job traveler and all the others, or you can go into the job management reports, go to job traveler. And if you check this box, print all jobs that are flagged for mass print, you'll get your travelers. So either way works, going into job entry, calling up a job, an unfirmed job, firming it up there and printing it, or the thing with the job status maintenance is it allows you to grab multiple jobs at once. But remember that MRP, when I created that unfirmed job, back into job entry for a moment. This job has a method, and it's been scheduled. It's just waiting for you to firm it up. And that's why if we look at the job scheduling board, a job. So this job has a single operation, which is inspect. Yes, no.
Oh, you're asking?
Yeah, I mean, I've never seen it. This job says you're inspecting it. Well, how did you make them?
I don't know the part, so. 0629. I don't know why that's like that.
Is the material that's required for that, is that a purchased material? They're probably buying a finished part.
And running it through QA to.
And just running it through the job for inspection, and then they'll receive it probably to stock, is my guess.
Well, couldn't they just use the incoming inspection flag?
Yeah, they will eventually.
All right. So yeah, that way you would just create the PO to buy the 0630 part. When that came in, it would be destined to go to inspection. It would be inspected. If it passed, it would move to stock so you could use it somewhere else. Or if it fails, it would go to DMR.
Right.
Now, do you have advanced production and scheduling module?
We have the module. I don't think we use it. Do we, Joe?
And what was that for? Production scheduling?
The advanced production scheduling?
I believe to use advanced production scheduling is MRP, right?
No. So
Do you say no?
One of the things that you can do with the advanced production scheduling module, you have access to this multi-resource scheduling board. So what you can do is you can select multiple resources and see them on the scheduling board in one spot.
Yes, and there are, I know there's a few plants that do use that. I think Ohio Rod uses that quite a bit to view more than one at a time.
Right. The other feature that you have when you have APS, or Advanced Production Scheduling, is when you create an operation, I won't save this. When you go up here and you say, I want to, now every operation needs to be linked to either a resource group, or with APS, you can link it to a capability. Out there. Nope. So think of a capability as what can be done. So, for example, we'll take a simple one. Drilling. Drilling a hole. Drilling can become a capability. And then you can link that capability. It could be done on a drill press. It could be done with a manual drill. The worst case, you could drill a hole on a lathe. So what happens is when you set up your capabilities and you link an operation to a capability, one of those capabilities, when you link a capability, one becomes the primary resource group. However, if the system can't schedule it in the primary resource group where that capability happens, the system can begin to branch out and look to see what other resource groups have that capability. And then what it will do is it will say, let's say the standard is going to be, I want to do it on a drill press, but if where I go to schedule the engine, schedule the job operation, that drill press is already full, then what system will do is it will start looking at other places where it could find that capability. And so it might say, okay, in order to help get this job done on time, and the drill press is already full, I'm going to have you manually drill a hole. That's how the system uses capabilities. And in order to get access to the capabilities tab, you need to have APS, Advanced Production Scheduling.
We need to get the scheduling to work to begin with, and then we can maybe look at that.
Yeah, yep. The other thing that I typically tell people is if this is their first venture into having the system do scheduling, that they should maybe think about not checking any of the resource groups off as finite, get a handle on using things like the overload informer and the scheduling engine, going to the scheduling board, moving things around, and then when they're comfortable, start to turn on finite. And in some cases, what a customer will do is they will have, let's say, a bottleneck, one resource or resource group that is their bottleneck. They might turn on finite scheduling just for that bottleneck and let the rest of the operations be scheduled in an infinite mode. So let's say that they do a machining operation and then they have to, let's say they could do their own heat treating in-house. Well, their oven can only take so much stuff, so they might say, we'll turn on that resource as finitely scheduled, and then once it gets through there, after it comes out of heat treat, maybe we do another machining operation, and then maybe we do some type of assemble. We'll let those be infinite, but we'll take our bottleneck, if you will, and we'll start with that under a finite mode. And then, again, as they get more and more comfortable and used to that exposure, they might turn on finite scheduling on other resources. But the key is, when you're going to infinitely schedule, then you'll want to make sure that you run the global scheduling so that you can take a job and, or take all your jobs and reshuffle a deck, if you will, to make sure that the jobs now are being lined up accordingly where they should be. Because in an infinite mode, it's very easy to go into the job scheduling board and move one operation up or out and then look at what you've done to yourself. Maybe you've caused an overload in another area, but that's fine because the overload informer will tell you that, or you'll be able to see it as you're doing it, and then you can figure out, well, what can I do to overcome this? Do I work overtime? Do I move something out of the way? Do I move something to run earlier? But that's not so easy when you finite schedule, because the system's not going to let you put a job just anywhere you want, because if there's already a job out there, it's going to say, I can't put it there because under finite rules, I can never be overloaded. So when the finite scheduling engine runs, scheduling technical guide will actually tell you the algorithm it uses.
Hello. No.
print this, by the way, too. And I think I might have a document that ripped it out of here that I can send you.
Jim, what I would like to know is, in the system is determining an overload situation based on the capacity of a resource, right?
Yep.
So we have to make sure that our resources are defined with capacity.
The correct calendar, correct.
The calendar,
Calendar is what supplies the system the number of hours and days that it can do its scheduling. So that's why when we look at a resource group,
but there are, and tell me if I'm wrong, but I think at Telefast there are certain machines that run faster than other machines, but the job can run on either one of them. So like one might be, I don't know, maybe 100 pieces a minute, and another one's 80 pieces a minute, or something to that effect, or per hour. But there's a difference, but they can both be used. You know, they, in essence, are the same operation. It's just that one's on one and one's on the other, and the rate changes based on the resource that's required.
okay? So what you can do in the method is you can, when you create the method for a part, you can say, in a perfect world, we want it to always run on a faster machine. But when you create a job and you pull that method into the job, what you can actually do in the job itself, I'm going to find a job. So let's say that this particular resource, the B machine, can run this part, but it's different. Then this is where, on this particular job, you could say, although when I pull the method in, we're going to run it on number 6 Waterbury, for whatever reason, I'm going to run this on the number 6B Waterbury. And then what you'd also want to do is once you select that resource, you'd want to go back in here.
But if I didn't, Jim, if I didn't pick a resource and I picked a resource group, and
right.
the number 6 Waterberries were all part of that operation, the Faro operation.
Yep.
And I didn't pick a resource, I picked the resource group for that operation. Would it know that there's another job that, you know, if I had my scheduling block at 1 and I have 2 resources within that resource group, it would know to schedule, well, the one is scheduled on the faster machine, it would automatically schedule the other one on the slower machine. How does it know the rates?
No, it doesn't. That's why if those machines are interchangeable, then they should definitely be in, then there's really no work you have to do other than when the system, because this operation is tied that this is going to be the primary resource group. And let's say that you had the two resources tied to this operation, number 6A and B. A, if in a finite world, then the system would see A was completely full. It would automatically move it to the B. But in an infinite world, then it's going to schedule it on A till you're overloaded. But in the job record, you could say, we're going to use the B machine. But the important thing is then if B is not, can't do the 48,
well,
you're going to have to change that to what it can handle. Because remember, the operation is what's supplying this number. Not
right. No. I understand. Show me the, what's the purpose then, if I go into the resource of the Waterbury Farrell, number 6A, if you go into that resource itself, and the resource setup, yeah.
Okay, so we got to go back to the, we got to find out what group this is in.
I don't think it's in a group right now, is it?
So every resource has to be attached to a resource group. Do it this way. We go in operation entry. Number 5, A and B.
There it is.
There it is.
875A.
So there's the resource group, and there's the resource that's attached to that resource group.
Okay, go back to the resource group there. That's it. See the detail there. The daily production capacity, what's that for?
Okay. When you have APS and you have a resource that is not time constrained, but pieces constrained, you put in the daily production capacity the number of pieces it can handle. So think of, we have customers that have a paint line, and on the paint line, they have only so many hooks on the conveyor that goes into the paint oven. So it's not a matter of time, it's a matter of they can only paint 250 pieces a day. So that's what the daily production capacity is when you have a resource group that's not constrained by time, but combined by the number of pieces that can go through it.
Right. Now let's talk about that scheduling section there. the number of resources, if we had an additional resource within here, we'd have 2.
Yep.
Is there an assumption that they can be, they're the same capacity, the same, throughput? How do I?
Well, you can change the capacity, because then what you would do is you would put on the resources, you could put separate calendars. So let's say we've got resource 1 using the TF1 calendar, and I won't save this. I'm going to create another resource in this same group, and I could say, however, this machine uses this calendar. And now, when something gets scheduled to the number 6 Waterbury, number 6A, it's using that TF calendar. When it gets scheduled to this, it's using an entirely different calendar.
No, I understand that, but if we go back to, I have a second Waterbury that is not as capable. It's a little slower machine. How does that get defined in here?
It doesn't. It gets defined in you would have to have an operation, because, and then when you link the operation to that resource group, then in the job structure you'd have to say that here is, because you could do it in a method, but if you're talking about the same part, you'll notice in the method of manufacturing is where you define how long that operation takes, and the method of manufacturing gets pulled into the job. Well, if you decide that you're going to run it on a different machine, and that different machine doesn't have the same throughput, then in the job record, you're going to have to go in and say, this, where we're going to run it can't do 48 pieces a minute, it can only do 46.
Okay.
Now, I guess you could do something, but it's still going to require a completely different method. You could create an alternate method. And an alternate method is just an alternate routing. So when you have a part, so let's go back to here. Part. So now when I create an alternate and I go into the engineering workbench, I can pull in that standard that says we always run this on resource group 6A, and the production standard is 48 pieces per minute. I could say the alternate says that we run it on 6B, and the production standard is only 45 minutes per piece. And then, I'm not going to, again, because this is your live, I'm not going to save it. Then what happens is when a job is created, and you say, get details, well, you'll see in this box, you'll see 00, and you'll see alternate method A hung from 00. You would select the alternate method A, and then what that would do is it would bring in that this operation is going to be run on number 6B, and this is not going to be 48, it's going to be 45. So rather than you have to change it all the time, you can say, I realize when I create the job that I'm going to have to run it on the alternate method. You'll see sometimes customers will use that if they have an operation that normally they do in-house, and if they know that that operation cannot be done in this time frame in-house because it's overloaded, they might have an alternate method that says, the alternate method says for up 20, instead of us doing it in-house, we're going to do it as a subcontracted on the outside.
Now, as a standard, when we've set up looking at resource groups and resources, what we have typically said in the past, and maybe we need to revisit that, is that if you've got a group of machines that can run the same jobs 95% of the time, that would be the same resource group.
Correct.
Because 90% of the times they don't know if it's going to run on machine 6 or 8 or 10, even once they firm the job. So instead of having, if they've got 2 machines, instead of having an 18-hour day, they would have a 36-hour day, and they can run it on any of those 2 machines, even if your standards fluctuate a little bit.
Right, right. So yeah, I mean, that's what most people do is if the machines basically have the same, can do the same work, they put them in the same resource group. But if one is a little bit slower or faster, then in the method they always try to say, we'll always use the faster of the machines, but then at the job record, if they see that that faster machine isn't available, then that's when they can say, I'm going to go to the scheduling resources, and instead of using machine A, I'll use B. But if they don't have an alternate method, and there's a substantial difference between the number of pieces that the B machine can run as a production standard instead of an A, then they make that change. You know, if we're talking about 48 versus 47, I don't know. I mean, are those numbers that dead on that it's really going to make that big a difference when you're making 240,000 in a clip? But if you have an alternate method, you at any time can go to a job. As long as the job hasn't been started, you can say, delete my method, and I'll go get the methods again, only this time I'll bring in the alternate. Or you can, as I said, go into the job, go into the scheduling resources, and change it from A to B, but then the onus is on who's ever doing that to go back to this production standard and make that change there.
Okay.
Now the other thing that I noticed about this job is that this material has been tied to up 10, and that operation shows as being complete. However, this was the only material issued to the job. All the rest of this material is in fact tied to up 10, but they never issued this part. So again, the question would be, how did they complete this operation if all the material wasn't issued to the job? So what this is doing is, if we look at any of these parts, and we go to time phase, you still need these coming from that job record.
These are
The job operation shows as being complete, but they were able to complete the operation with not all the material.
yeah, that I think that's tooling. They're calling out the tooling as a part.
Okay. So all this is just the tooling stuff. All right. Also, you'll notice on a job, there are two boxes. There is a lock box under the quantity, and there's a lock box under the schedule. If you move to finite scheduling, and you lock a job schedule by, in job entry, clicking down here once the job has been scheduled, when the scheduling engine runs, that global scheduling, one of the first things it has to do is it has to honor your locked jobs. So although it might think that something else should be running in that time frame, if you have a job locked there, the system says, I'm going to have to leave it there. Because otherwise, what would happen is you'd go into global scheduling, you'd manipulate your schedule, and you say, this is the schedule I want to run with, and then global scheduling might run. Typically, most people put it in a nightly job stream and run it. It runs, and it would say, all right, I don't care that you think that this is what should be run on this resource come Monday morning. I'm putting something else in its place. If you lock it, however, now the system says, I have to put your job to be run on Monday, and if there's any time left over, I can put other stuff in there. Otherwise, I got to move to the next available block of time. So locking a job becomes important in that if you say, this is where I want it to run, then you want to make sure that that job is locked and the scheduling engine will honor your lock. And let's look at something else. There's a setting in your company config that has to do with operations that are already been started. Go to modules, go to production. Okay, good, you don't have that checked. If you had that checked, then what the system would do is, even though a operation has been started, the global scheduling engine might tell you to run something else on that machine. So typically, you don't want to check that, I think, because if you set up the machine and you started to run a job operation on that machine, on that resource, you don't want the system to come along and tell you to stop and break setup and put something else on that machine. So when you do have to run this, unfortunately they put this in alphabetical order, but here's what needs to be done. You need to run the calculate global scheduling order first. After this runs, if you want to see the results of what was done and possibly change anything, you go into the adjust global scheduling order.
Jim, does it hurt for us just to run it?
I don't know how many jobs you have out there. I don't know how much time it would take, but
Shouldn't, I don't think
try
it would take.
that. So there's the start date, there's the start time. You can name your log file. Don't put a name. It's going to create the log file, and it's going to use, under the reports folder, it's going to use J. Pastor, because that's who the logon was. It's going to be in that folder, and it'll just say log file of 11.1. You can run it either in the basic log file or process and scheduling. Process and scheduling will show you the most detail because it will show you the part and the schedule and information about the schedule. Basic just pretty much says that it ran, here's was the start time, it looked at this many jobs, and it had a successful ended job, you know, an hour later, 20 minutes later, whatever. Number of processes. You see the same thing on MRP. Unfortunately, the right number is not something that you can get from anyone from Epicor, including people like Ben Nixon, the hardware group. When I ask them, this is what they tell me that you should do, is you should put in a number, let's say 3 or 2, run it. When you look and see how long it took, the next time you run it, go from 2 to 3 or 3 to 4 until such time that increasing the number doesn't change how much faster the process actually runs. What this is doing is it's saying, I want to dedicate this number of machine processes to running this. Now, in theory, the higher the number, the faster it would run. But there is a point of diminishing returns, and that's what he's saying is that if you get up to 4, and there was no difference really between when you had it set to 3 or 4, then just leave it at 3. If you're running this at night in a nightly job stream, you can afford to add additional processes to it. But during the day, if you make it too high of a number, the rest of the folks who are doing processes, because you're live, are going to notice a slowdown because you're stealing more of the machine's processes to run this process, and therefore they don't get as much machine throughput as they would normally see. So I'm going to make this 2 for the time being.
No, we don't, Jim, we don't have a finite time schedule, do we?
Oh, you have MRP Daily that runs at 5:09. Like there's a daily 1 a.m., 2 a.m., 3 a.m., 10 p.m. So if you wanted to, excuse me, you could add this to one of those existing schedules, and then it would run every night. you have the pop-up balloons to automatically appear?
That it's running? I think it'll tell you. When it finishes, you mean?
Yeah. Yeah, if you check these status balloons, and this is by user, by the way, now you'll get a pop-up message when the report is run successfully, or you get a pop-up error when
Fails.
Because prior to us badgering Microsoft to give us this capability, typically what would happen is you would run a report, you get no item selected, and if you're like most users would wind up clicking and say, oh, something went wrong, I'll run it again. And until they went to the system monitor and went to the history task and saw that it ran with no item selected, they had no clue. Now, when you do this, if the report is run and no items are selected, down here you're going to get a little pop-up window that'll say, report ran, no items selected. Or if it ran successfully, it'll tell you it ran successfully, and then soon after you get that message, to report, if you did a print preview, will pop up on the screen. And the same with processes. So when this process is done, we're going to get a pop-up message that says it is done, and it will automatically move just like anything else from the active task to the history task. So you have to run this. You don't really have to go into the adjust global scheduling order if you don't want to make any changes, or if you do go in it and make changes and save it, then the third process you'll run is this global scheduling. And again, when you run this, you can say, I want to run it in the what-if mode only. And then if you run it in the what-if mode, that's where this change impact informer can be used. Now you get this pop-up that it's done. That if we go into the scheduling order, so this is the first job it's going to schedule, because it's got a scheduling sequence of 10. Well, if I took this job here and I say, I made this scheduling sequence 21. Now, right after this job, it's going to schedule it before it schedules 30. And when I save this and then run the global scheduling engine, the system is going to say, well, based upon that change you made, I'm going to schedule job 10, schedule job 0028937. Then I'm going to schedule this MRP job. Then I'm going to schedule job 0028936, and then go on to scheduling sequence for 30, 40, 50, and so on. If any of your jobs had their schedule locked in job entry, you would see a check mark here to say that these jobs are locked, and it doesn't look like you have any jobs that were locked. Because again, when the global scheduling engine runs, it has to honor your locks and schedule those jobs and then do what it calculated. So the last step of that would be to run global scheduling. And by default, it's going to infinitely load, but it will only infinitely load those resources that are flagged as infinitely load. I could do the what if mode. Otherwise, when I submit this, so again, I'll just change that slightly. It will go out and it will schedule the shop. Now, again, we don't expect to see very much change because of the fact that you don't have any resources flagged as finitely scheduled. You'll also notice when you have APS, you have access to a field in the part record. I'm going to do a search here. Called constrained material. By checking a box that says I'm a constrained material, then what the scheduling engine does is when it runs, it will determine whether or not the material will be available for an operation. So constrained material tied to an operation, it has to check and says, what's the point of scheduling that operation to be run if the material is not available? So if the material is flagged as constrained, it will go here. It will go to the operation that the material is linked to when it's scheduling the engine and use the date the material will become available as a starting point. If the required date is later than the defined lead time for the material, then the application considers the material will be available. So we're scheduling something and we don't need the operations not due to start until January 15th. We might not have any material here today, But what system is saying is if the lead time of that material is like 5 days, system says, well, then we can get it within 5 days. It will therefore be available on January the 5th. Do you typically buy all your material to stock, or do you buy material directly to a job? So do you have purchase material flagged as purchase direct, make direct, non-stock?
Most of the plants they purchase it for stock and then they issue it to the job.
All right.
Vegas, I think, is a lot of purchased to the job.
If they purchase to the job, then they don't need to worry about clicking the constrained material, because the scheduling engine will see that that material is being brought in directly in response to that job operation, and says, again, what's the point of me scheduling the job operation to start when the material is not available? But when you buy material to inventory, because you have APS, you have the ability to say this is a constrained material, and now when the scheduling engine runs, it's going to look at where this material job operation is required, and then it's going to come over here and look at your lead time and see whether or not that material will be available. If the lead time is less than when it's required, it's going to say I'm available. But again, this particular part doesn't have any lead time. Part. So am I just real unlucky that all the parts I'm picking have no lead time, or don't they have purchase parts? They haven't identified lead time on the purchase parts.
Yes.
Yes, I'm lucky, or yes, they haven't defined lead time on purchase parts.
That's another area that needs to be improved.
Yeah, because remember, when you run your MRP, or if you run generate PO suggestions as a standalone process, what system does is it looks at when you need the material based upon the job, and then it's going to back off and tell you when you should order the material to have it here on time. Well, when you tell the system that the lead time is 0, the system says, well, if you need them, you can go ahead and you can get them the same day that you need them. If I go down here to time phase as an example, we can see that we have quite a few on hand, and that's going to run us out until whenever. But let's say that it needed to give us a suggestion to buy more. It's going to say, if you got a demand out there for December 1st, you can buy them on December 1st because your lead time is 0. The other thing that I noticed about these jobs that require this material, that they were released, but they have no date. So that's why time phase put them there, but MRP, and even if you did have a lead time on this purchase part, system says, I don't know when you really need this stuff. So if I go to Job Tracker, Yeah, it's just, it seems that time phase is just taking a little longer to bring in the dates. Because I thought, you know, if you ever have a job, or if you go to time phase and you see demand without a date in there, that's usually an indication that the job wasn't properly scheduled or not scheduled at all.
Sometimes, a lot of times I see in there where when the MRP runs its scheduling, if it's not going to meet its due date, sometimes it won't put a date in there because it can't schedule it because it's not going to meet its due date.
Typically, MRP should drop it there and it will. You might get a suggestion that says to expedite the job because it's not going to meet its due date. Let's take a look at why the other thing is still running. Let's look at MRP. All right, so you can run MRP either in the net change or full regen mode. If you put a cutoff date, this is how far out in the future you want MRP to plan. If you leave it blank, it's going to go out. Got a demand out there for 2 years from today, it's going to look at it and plan to it. Scheduled start date is always defaulted to today. When you turn on finite in certain resource groups, then you'll want to make sure this is checked, and now MRP will actually run finite scheduling when it's scheduling the order. If you uncheck ignore constrained materials, now if you have any materials in the part record marked as constrained, the system will just ignore that. Allow historical dates. If that's checked, what it will do is if there's something that you should have taken action on yesterday, it will tell you that the demand or the action you should have taken should have happened yesterday. Right now, with not allow historical dates, it will see that that demand should have happened yesterday, but it's going to tell you take action on it today because today is the scheduled start date that we ran MRP. Short level 0 MRP jobs by date just says that after it runs, will it look at all the level 0 jobs and schedule them by the date they're required. You typically don't have to check that if you don't have very deep, complex bills. The system will schedule everything just fine as it is. Recycle MRP jobs says that, you know how you get those big numbers for MRP jobs? Well, if you didn't use an MRP job number and you have recycle, it could use that job number again in a full regen. So the numbers just don't keep getting bigger and bigger all the time. It goes back and kind of fills in the holes. Get details from quotes. That says if you are using the quote module and you've gone and let's say you have a part and you modify the method of manufacturing inside the quote, you want MRP to use the structure that's in the quote file, yes or no. If you do, then we check that. Run multi-level pegging process is there's a program out there called multi-level pegging display. But in order to run multi-level pegging display, the process called multi-level pegging needs to be run first. Well, you can either run it as a standalone process, or if you check the box off when you process MRP, it will automatically run that process for you.
What's it do then? It pegs the supply to the demand?
Yes. Well, we always do that anyway. It's just that if you have like a fairly deep bill, you could see that when I go to time phase, you could see that a particular part is being called out for a particular job. And then if you look at what that job is to make and you pay that, you might see, well, that's because it's a subassembly being called out for against another job. And you could wind up going into time phase multiple times, chasing up the chain, whereas the display multi-level pegging will do that for you in one spot. However, when you look at it, you need to kind of think backwards, because what you think of supply will be listed as a demand, and when you think of demand will be listed as a supply in the multi-level pegging display.
Oh, got it.
Then you have the ability here, just like you did before, is to have a log level and say, do we want basic information or do we want MRP and scheduling? And then you have down here the number of processes, and because it's creating jobs that are scheduled, you can put in the number of schedulers it should use. And then you can tie it to a nightly job stream or run it immediately. After it runs, if you go into job management, general operations, and go into your planning workbench, I'm just going to say for right now, I just want to see new. What appears on here will be non-stock demand. As a matter of fact, you don't even need to run MRP. If you have a part, go into that's either coded as a non-stock item or in the sales order, you flagged it as you're going to treat it as a non-stock item, then immediately it'll wind up on this planning workbench. So, for example, here, if I go to this sales order, you'll notice this is flagged as make direct. That's because this part number in your part database Oh, must be a part on the fly, that's why. So any part that is not in the part database, but rather is a part on the fly, is automatically going to be defined as a make direct item. And so that's why it appears in the planning workbench. The only time you'll see new here for a stock item is when there's a situation that, let's say, MRP couldn't create the job because it's a manufactured item with a no bill or the method is unapproved. So MRP says, I couldn't, normally when you ran MRP, excuse me, MRP would create an unfirmed job. The job would have structure, it would be scheduled, but if the part doesn't have a bill or the revision isn't approved, it says, I can't do it. So it puts it on your planning workbench and says, you need to fix this. So those items that appear on the planning workbench, if they're stock items, is telling you, you need to take action. MRP couldn't the last time MRP ran. Now again, this, I don't know when this demand got put in the system. Maybe when, you know, we run MRP, MRP will take care of it. Scheduling is still running. So again, from the table point of view, you need to make sure you have your resource groups, and then within resource groups you have resources set up, operations, because an operation links either to a resource group. So for some customers, when they have a situation where they have multiple resources and they're completely interchangeable, they'll schedule to the resource group, and they'll, when the job hits the floor, they'll let the foreman say, okay, today we're going to run this on machine number 6 as opposed to number 7, just because number 6 is available and I'm going to run it there. The other thing that you'll want to do is you'll want to fix your production calendar. So I'm just going to create one for you just to show you what I mean, to get away from the hours that you're really not there. I'm going to go over here and say 24 hours, but we start at 6 in the morning. So I'm going to say, 6, 7, 8, 9, 10, 11, 12. And I'm going to click Sunday and get rid of Sunday. Click Saturday, get rid of Saturday. And now I'm saying this, we start at 6 in the morning and we go here. The other thing that you'll want to keep in mind is if I say this is really my 8-hour calendar, I've only defined 7 hours because right now if you look at our resources or resource group, there isn't really a field called utilization. How many hours of the day is this resource or resource group actually utilized? So a way around that is to basically say, although it's an 8-hour shift, we realize that between lunches and breaks, and when someone first punches in the morning, and punches out of a job in the afternoon, maybe 5 or 10 minutes before the end of shift, so they can clean up around their machine. We really want the scheduling engine to only consider 7 out of those 8 hours for scheduling. I mean, I could use all 8, but then what I'm actually saying is that the resource or resource groups that point to this calendar, they're utilized 100% of the time. Out of an 8-hour day, they're always running. The other thing you'll want to do with your calendars is you'll want to go up to your working days, and you'll want to make sure that you've identified when you're not here. So, for example, if we're going to be off Christmas Eve, I'm going to say that the 24th, the 25th, and the 26th are non-work days. What does that mean to the scheduling engine? The scheduling engine will never create a job either to start or to finish on a non-work day. So if it needs to schedule a job to start on the 24th, it's going to defer it and say, you got to start on the 29th because we're not here the 24th, 25th, or 26th. And we've already defined in the calendar itself that we're not here on Saturdays and Sundays. Now, we always get asked the question, what if we're going to work this Saturday? What should I do with my calendar? Usually, what we tell people is do nothing. However, if you said that realize that you're behind and you're going to work the next 4 or 5 Saturdays, then you should come in here and say that the 8th I'm going to toggle and make it a work day, and we're going to work on the 15th, and we're going to work on the 22nd, and so on. Okay? But if you're just working a single Saturday, most likely you're coming in to work on a specific job or a group of jobs, and you already know what you're going to work on. So by the time you would update your calendar, reschedule the entire shop, you'd probably be halfway through Saturday anyway. So if you're going to work, you know, like I say, the next 4 or 6 Saturdays in a row, then you might want to go into working days and identify those Saturdays and Sundays that or Saturdays that you're going to be there. And again, the hierarchy that the system uses is when I look at a resource group, if the resource has a calendar, it'll use this. If this is blank, then it says, I'm going to use the resource group calendar. So every resource doesn't have to have a calendar, but you could have a calendar when it's different than what you normally work. You can also, this, put a calendar on the plant record. And now, when the scheduling engine runs, if it sees that the resource doesn't have a calendar and the resource group doesn't have a calendar, it will go and say, does the plant have a calendar? And we'll use the plant calendar. So, for example, I have a customer that they manufacture equipment for the mining industry. they have their own foundry. The foundry resource group, they work 24/7 because once those furnaces are hot, in addition to them pouring for their own use, they also advertise that they will pour for other customers. So when you look at their resource group, the foundry has a 24/7-day-a-week calendar. Their machining, fabrication, assembly, all those other resource groups have no calendar at all, and they put their 16 two-shift calendar on the plant record, and now when the scheduling engine runs, if it sees it's something that needs to go through the foundry, well, the foundry has its own calendar 24/7 linked to the resource group of foundry. It uses that. If it goes to schedule something through fabrication and sees that there is no calendar on fabrication, it goes to the plant, and in the plant they say it's 16-hour-a-day calendar. So that's why there's a, in fact, the help will tell you there's a hierarchy to when the system needs a calendar. It's going to start at the resource, move up one to the resource group. From there, it's going to go to the plant record. And actually, you store that in the plant record, your plant record, there was no calendar. The only place a calendar is absolutely required is your company config. So you really should have a calendar defined here in a company. That'll be the last place the system would look. If it can't find a calendar on the resource or the resource group or the plant, it will go to the company config and say, I'm going to use this calendar. Resource type is an optional field that you can set up. It has no bearing on how the system will do its scheduling, but what it's used for is when you're in a resource group, go to a resource, you can say this resource type is whatever it is. So for some customers who in their resource group, as a resource in a resource group, have both machines and people to run them, they will have a resource type, and then they'll say this is the machine resource and this other resource could be labor. And then what they would do at that point is it can be used for reports and queries where you can say, show me my resource types that are machines versus labor, versus people. But it has no impact on how something gets scheduled. It just helps define what these resources are within a resource group. And then you have your departments, because you'll notice when you create a resource group, a resource group needs to be linked to a department. And then there are reports, both in scheduling and job reports, like the priority dispatch report, that you can run, and you can run it by department. So you can select only a handful of departments or only a certain department, and then it'll find all those resources that are, and resource groups rather, that are as part of that department. That's why you have the filter summary, where you can select only certain departments or certain resource groups and look at your priority dispatch report. Do you run this currently?
No.
Okay.
Can you run it once just to see what it looks like?
See, I want to see operations that are due to start on or before today. I can say I want a page break every time I change the resource group. I can print only labor resources only, or list all scheduled resources. You use MES, the shop terminals.
Some places.
Okay. On the MES, there is an electronic version of the priority dispatch report. So that as an operator, I can go in and swipe my badge, and then instead of me going and telling what the system, what job I'm about to start at, I can actually go to what is called the work queue. And when I look at the work queue will show me what work is in my resource group and or department that I can select to work on. The report is, I'm going to get away from subcontractors. The report actually prints in, there are 3 sections to the report. There is available work, current work, and expected work. Let's see, in this we got some current work. Here we have some expected work. I was looking to see if we have any available. So here's what each one of them is. Available work says that I'm the first person out of the gate, or I'm sorry, I got that backward. Current work says that it's in process or 100% complete through the prior operation. So now it's with me. And so in this case, in the resource group PM754A, job 002871, if there was an operation in front of it, which there wasn't, because you notice it's assembly 0 operation sequence 10, it's telling me that I'm the first guy in this case, so I can run this. You'll notice it also will give you the priority code. So for a lot of customers, they use, although the priority code is primarily used in the scheduling engine when you infinitely schedule, because it appears on documents, they basically make sure that they train their users, their operators, to say, when you see 2 jobs that both should be run today, and one has a high priority and one has normal. You do the high first, and when you're done, then move in and do the next. Then you can do the one that says normal. So available work, unlike current work, says that the guy in front of you, the operation previous, while it's not 100% complete, has started to report pieces complete. So that if I needed work, I could go to that operation where that operation is being performed, and I could find pieces that I could start to work on. So current work says it's either in process, 100% complete through the prior operation, or in this case, I can see that all of these jobs, op 10 is the first operation that's going to happen. Expected work says, while the prior operations haven't even been started, these things are going to come to you. And so if I look at that first one, it's job 0027554, op 50 is done through here, and the setup hours is 1 hour of setup. Estimated production is 11.90. So again, the priority dispatch report can help do some planning and say, I know I'm going to get this. I can look at the job and see when op 50 is scheduled for, so that maybe I can see, you know what, maybe we're going to have to come in this Saturday because to clear up some load that I have. So this, as I say, there are 3 sections to this report. Current work means I got it, or the guy in front of me has completed 100% of it, so it's on its way down to move to my area. Available work says the guy in front of me has, although it's not 100% complete, has started to report pieces complete. So if I really have no work, I can go get those number of pieces and start to work on them. And then expected work says no one started anything yet, but you can expect that this is going to come to you sooner or later. And as I said, if you use the MES terminals, there's actually a electronic version of the priority dispatch report, and it's called the work queue. And as an employee, in my employee record, if I go up to employee, there's my department, so that this employee through MES can go to the work queue. The work queue is going to show him all the work that's in department quality. I can change that and say that, let's say my boss told me I was going to work in this department for the day, and then I could see what work is in that department, and within the department, what resource group or resources. Shop load, when I run the shop load report, it's going to ask me for a cutoff date, and it's going to default to today. It's going to say, it's going to set up buckets for me. So I want them weekly or daily. Intervals is going to default to 1 week, but if I made it 2 weeks, I'll get more data, but I'll get weekly 2-week buckets. If I say make the first bucket infinite, that says that any job that was due to be started before 11.3 is going to show as load within the 11.3 bucket. If I say summary only, what I'll see is load, I'll see capacity, and I'll see load, and I'll see if there's any left over, but my load is simply going to be a number, 24. If I don't check summary only, I'll see 24 hours worth of load, but I'll actually see what jobs make up that load. And I can filter it by only certain departments or resource groups. Otherwise, when I run it, go to production. So it says that this job, so department production, resource group BM375A, says that through 11.3, I have load of 18 hours. And because I didn't ask for it in summary only, what I'm seeing is the jobs that actually make up that 18 hours worth of load. Then we go out to the next week from 11.4 to 11.10. I've got load of 6.67 hours. And then the next week, and when I go down, then it gives me my total that says I have load of 116.6 hours. I only have capacity of 18 hours, so I've got 90 minus 98 or 98 hours over my stated capacity. And then if I look at the next bucket, I've got load of 6.6 hours, 6.67 hours with a capacity of 80 hours. So I have 73 hours worth of additional capacity in that week. And the following week, I have no load, and I have all my 80 hours, and then 12.66, and so on. If I would have said make the intervals two weeks, I would get more data going out, but my buckets would be 2-week intervals. If I said day buckets, then I'm going to get 1, 2, 3, 4, 5, 6, 7 days. And that's the shop load report. Now again, because we have no resources marked as finitely loaded, it really didn't make, a difference. You can see the actuals are 89 jobs early, 38 jobs were on time, and 347 jobs are late, but there was no change involved in running that. These gray stays, they can be defined in the company configuration. And what it's saying is, if a job needs to be moved, let's say it's now going to be early by 2 days, because 2 days is inside the early grace periods, it won't be counted as a change to the early jobs. If it was on time before, it'll still be sitting there as an on time. If the system had to move it greater than 3 days, then yes, it'll be listed as now an early job. And you have that late grace period for late jobs. So if it got late by 1 day, it's not going to be listed as a late job. It's not going to be counted in this number, if you will. But if it's late by 4 or more, it will be counted in this change of late jobs. And that can be set your company config. So again, the job scheduling board, you can run it as a standalone, in which case you'll have to identify what job, or you can be in job tracker, job entry, and launch the job scheduling board from there. The resource scheduling board, when you run this, you can either do resource or resource group. If you select resource, then when you click the button here, what you're doing is you're finding first the resource group, and then the resource within there, and then when you go to schedule, you can see all of these jobs are late because they all have a red on them. And right from here, you can right click and say, take me to the job tracker. And we see that the required by date says 11/12, and the scheduling engine said you're not going to make it until, you're not going to be finished until 12/10. So that's why the operation is going to be late. And if we go up to the actions schedule and look at the job scheduling board, we can see how the operations got scheduled. So we're doing up 10, and we're going up 20, up 30. We have the inspect operation, which probably has minimal time on it. That's why it's such a small. In fact, there doesn't look like there's any time at all on inspection. And we go to up 50, and we go to an outside operation. And this operation which is your health plan operation. There's 7 days out on that up, and up 50, another 7 days, and another 7 days on up 60, and then you got your packaging operation. So system said, if you start here, looking at and summing all the estimated hours and estimating the days out for outplant, you're going to be done on 12/10. And here's a list of materials you require. And you can see right from here that with the exception of material 10, there's an exception on all these other materials. And if we go up here to actions and job and go to material status, now I'm going to say 11.7, and I'm going to uncheck exceptions only. And I'm going to unpin this go to the list. And now you can see all of the quantities required, outstanding quantities, because we didn't issue any yet, and what your on hand is, and what your available is. So you can see a lot of these parts have 0 on hand. So that's why the system is giving you that red dot to tell you there's an issue with this material. You guys use this material status today?
I have no idea.
Okay. Pretty neat feature because you'll see that the minute you create the job, you can go to material status and you can see, all right, you know, I'm making 75,000. Do I have, you know, will I have all this material in-house by 11/7?
Yeah, again, those look like they're tooling that they use.
Okay.
And I think for the most part, Jim, they only have like one. Most of the plants only have one material there, and they'll go to time phase just to see where they're at and what they've got.
All right. Now, see, probably what they should do is they, in the method, do they really need 75,000 of these tools, or is it one per the job? See, because if they made the material and they said it was a fixed quantity, now the system says, hey, excuse me, although I'm making 75,000, because it's a tool, I just need one per.
Yeah, but it's not one per. That's the problem.
Okay. All right. So yeah, that's why they kind of did a quantity required of 0.004, which says they really need 0.3 of a tool. All right.
Yeah, because what ends up happening is that tool becomes it gets used again.
Okay.
in the next job. And
Right.
what they're really trying to do is to see the usage of that tool over multiple jobs.
Got it.
So eventually that shows up as a requirement to buy a tool.
All right. Yep. From your job tracker, you can call the
We'll use this
job scheduling board, or you can call it from standalone, same way with the resource scheduling board. So you can see that this is all the load.
And a few jobs in the sales if I really need a job. And I take that, like I look at the pictures of all the jobs for that machine, and so I click on them and it takes the time phase, and that'll show me my sales and my balance and all
what you
that.
need to
And I choose
go
what
back
I
and
need to make
change
it
your
on.
quantities.
Yeah.
Also, when you go into any of the scheduling boards, by default, it's only going to go out a month. So starting today, going out a month. But if you wanted to, you could say, you know what, take me out to the end of the month. And now if you have any load out there, you'll actually see it.
Yeah,
You can always make these
changeovers, but I don't know how many changeovers they have.
bigger for yourself to make them easier to read. You use moving queue time.
Some locations do. They've got it set up. I don't know that all of them have accurately the way they need to.
We use the queue time here at Chandler based on the backlog at each operation. So if we estimate there's, say, a week of work in trim, we would plug in 40 hours to show that it's not going to go immediately into the trimmer.
Yeah,
So whenever you're looking at
Leland's about the most accurate with putting those in.
when you're looking at the job scheduling board, if you want to see queue time, you can click this and you'll see the queue time. Or if you click it again, you'll just hide the queue time. This says, do you want to see completion time, yes or no? So if you leave it clicked, then that's why when we looked at that one job, we saw that green saying it was complete. And this is whether or not you want to show the original time. What that means is if I move something around, if I want to keep in place where it was and where I put it. So typically you'll want to do that. And again, if you go up here and you say undo, it puts it all back to where it was. And this will toggle your move time either on or off inside the scheduling board. This is what, when you go to preferences, this is where, how your colors, so the complete color is this green. Queue time, which is in front of the job, and then move time, which is behind the job. You can change these colors, but again, we recommend, or at least I recommend, you don't until you're pretty comfortable with the scheduling engine, because typically what would happen is, you'll call tech support and you'll ask them a question and they might say, well, send me a screenshot, and they're used to seeing, that the original color where it was blue, and where you moved it, is yellow and you made changes to these colors, they're going to go, well, they're going to figure out that they're going to come up with the wrong answer, or possibly come up with the wrong answer. Also, when you move something, over here you have some questions. You want to move just this operation only. You want to move the job and all of its operations. You want to move the branch and subassemblies. So if you have multi-level jobs where in one job you're building subassembly 1, a subassembly 2, and assembly 0, when you either select an assembly and all the operations, so if what you're moving belongs to subassembly 2, you'll move all the operations within subassembly 2. If you say, I want to move assembly and preceding operations, then it's going to move that assembly and any preceding assembly. If you say subsequent, it's going to move that all the operations within that assembly and subsequent assemblies. So again, this is where I moved it to. That's where it originally was. If this job wasn't late, the color would be blue. It's red because I moved it and it was late, and I'm trying to, maybe make it better.
Now, is there a way of turning those colors off? I've got a user at Ohio Rod that doesn't see any of the colors. He just sees, I believe, the yellow. And we couldn't figure out how to get his colors back. Is there a way of turning those off? If you don't know offhand, that's okay. We could do it outside of this call.
Yeah, I mean, here are the standard colors. I imagine.
Well, we could look at his, Joe. Maybe his are all screwed up.
I couldn't imagine that.
His user preferences got cooped up.
Yeah, that's what I'm thinking, because you can go here, and I believe there's a way to. I thought there was a way.
That's okay. That's okay. If you don't know right away, that's okay. Don't spend any time on it.
Yeah, I think there used to be a way that you could say add more colors, but that's the first thing I would do is I would check his preferences to make sure that his preferences weren't fouled up.
Okay.
Also,
I wanted to allow Jim a little bit of time. Are there any specific questions that people have? I guess not. Is there anybody still on here? That's the question.
I'm here.
I'm here. Scott from Chandler's back, yeah.
Now you guys are not, do you guys use this scheduling for very much at all?
No, not at all. We use we have the days out calculated for suppliers, and then with the queue times, we use it to give us an estimated start date, but it's infinite at the moment. There's no constraints whatsoever. So occasionally it'll tell you to start, 6 jobs on the same machine on the same day, but we just manually manage that to space them out, start some early.
How many jobs do you have at any given time?
that was going to be my next. That was going to be my question.
I'd say probably in total, everything in WIP is maybe 300.
Okay. You guys are about
I think so. I haven't
It's a lot.
said it enough.
There's a lot, I bet you.
I know there's a lot, yeah.
Anything else you can, thing you can give us a heads up on, Jim?
Well, let's just look at real quick at the So I see you're using the reschedule out delta. So what you're saying is if the MRP in scheduling says you need to move a job out by 1 day, you're not even going to get the message. After 5 days, you will get the message. Now you can also have a reschedule in delta that you can say, you know, if the system thinks we ought to run this tomorrow, tell me about it. But if I have a reschedule in, excuse me, of 5 days, then the system will say, I'm not going to bother telling you to run it 1 day sooner. But if we got to run it a week sooner, I'm going to give you the message because I'm in front of the delta. Now, you don't have to do it on a part-by-part basis, because if I go into the part class, I can do it by class of parts. And so when the scheduling engine runs, if it finds a value in the reschedule in or reschedule out on a part record, it will use that. If it doesn't, but you put it on a part class, it will use that. So, you know, if you decided that all the parts you want to reschedule out of 5 days, you don't have to go in every manufacturing part and do it. You can do it on the manufactured parts part class, and then by default, that's what it will use.
Gotcha.
So you put in a minimum lot size, so when MRP runs, if MRP sees that you need 200,000, you're going to get a job for 240 because that's your minimum lot size. If the system sees you need 260, it's going to say the minimum has been satisfied, and you're going to get it for 260. Kit time, if you put kit time on there, let's say of 3 days, it does not change the start date of the job. Instead, it calculates a field in the job header called kitting that you can create a dashboard and basically indicate to, by looking at it, that when the job ought to be kitted before you start the manufacturing process. So that's pretty much it on, you know, and receive time can be both on purchased and manufactured. It's basically, if it's on a purchased item, and let's say you have a 5-day lead time and a receive time of 2 days, it will basically tell purchasing that they need to bring it in 2 days earlier than the required by date so you can satisfy the receive time.
Well, related to that, Jim, and it's a little off the subject, but I did have a question on a customer expected, like if a customer expects to have it on their dock on the 5th of November, and there's a shipment time from our dock to their dock of 5 days, where would we put that?
Unfortunately, right now, unless you put a BPM in place, the only place you actually see that is if we go into a sales order. By default, every time you create an order, the need by date, well, here they did it. They said if the customer needs this on 2/28, you need to ship it on 2/25. But someone physically put that in there. Development has been asked about having something in the customer record, and their argument always is, well, does every customer order ship the same way all the time? Because that might be good if we ship it UPS, but if the guy's ordering, too many lines and the weight is over what UPS or FedEx will take, and we got to go to common carrier, is 3 days the right answer? Maybe it now needs to expand.
Well, and that's what's weird is because in demand management, you have where you can put a 3-day lead time in the customer setup, and it considers it for demand management, but it doesn't for order entry.
Right. Also, if they put a date on a header, then by default, every line will have that same set of dates, but they can change it on, let's say the customer says that line 2 we don't want on 2/28, but we want it on 3/1. They could modify it at the line level. And modify it as well, and that would be on
Deliveries.
the release.
Yeah. Okay, but the one that it's going by is really the ship date when it's done the planning.
Yeah. Also, if this was a non-stock item, then when the job got created, the job required by date, when we looked at job entry, would be
Ship a day.
ship. Yep, ship date. Absolutely.
Okay. Do you guys have any other questions for Jim?
I do have one question for you, Jim. I had asked it earlier, and you kind of gave an answer to it, but I'm still concerned with when you have an operation and you give it a scheduling resource group. What I have found, if you have a scheduling resource group and you also assign a scheduling resource to that same operation, that it doubles your time, and also when you quote the part, it doubles the quote for that part because you've got 2 requirements on there. Are we doing something wrong there, or is that?
Yeah, I mean, I'm not, if you could, when you get a chance, give Jim some screenshots that he could send to me. I'd like to look at that and see if I can duplicate it.
Okay, because typically I've always told users to only have one or the other, to not have more than one, because I have found that on quoting and stuff, it duplicates your time, that it thinks it requires both of them instead of being able to select one or using the default.
I've seen that, like, for example, if you had that the operation requires a man and a machine, then if there's any dollar values on the machine, it's going to use that. If there's dollar values on the man, it'll use that. Typically what we see in those instances is that in the resource group that's the machine, they'll put a burden, but obviously not a labor rate, and on the person who's running the machine, they'll put the labor rate there so that when they do a quote, the system will see that, the machine has a burden rate of X, and the labor portion is coming from the person, and then the system will say, okay, now I can use those values correctly because the machine doesn't have a labor value but has an overhead value, and the person is bringing a labor value to the party, if you will.
What we can do, Joe, is you and I can work on an example for Jim, and then we'll schedule another brief meeting just to go through it with him and show him.
Okay.
And then he'll be able to quickly tell us, what the issue is. So.
All right.
Okay.
Anything else, guys, before we wrap things up? And the answer to that long day is no.
Okay.
Well, guys, I do appreciate it. I really, this is just the beginning of us really starting to take advantage of the scheduling abilities within Epicor. And I really want to somehow get a plan together to start implementing it and start utilizing it. There's a lot of work to be done, obviously. There's a lot of parameters that need to be set up. There's a lot of information that needs to be entered to make it useful. Clinton said he doesn't want to, use his spreadsheet anymore. No, he does. But he wants to really start to utilize the system, and I'm all for that. So, and I know you guys at Chandler and Quality want to do the same thing. So,
Definitely.
But this is, again, just a start, guys. So we'll just keep trying to plug away at this and see if we can make it better. But I appreciate everybody attending, and Jim, thank you for all the effort that you gave us, or all the info you gave us.
All right, I'm going to send you a couple documents, too, to help you out.
That'd be great. And I've recorded this, guys, in case everybody wants to just go through it one more time. So, but I do appreciate it, guys. Thank you guys very much.
Okay.
Thank you.
All right, thanks.
Okay, bye-bye.
Bye.